Hi folks, so welcome to your first real lesson in Nat 5 physics, which will be about current and fuses. Now, some of this will be revision for you because we are building on the work you did in S3. So bear with me if it does look familiar. The difference is we are going into things in greater detail and greater depth. The questions will also be more challenging because you are now doing an official SQA course. If you've not done S3 before, don't worry, because the nice thing about physics that I love is that every time you start a new topic, we always start from the very basic stuff and we build upon it layer upon layer until we get more interesting and detailed kind of theories. Okay, so today we're going to look at current. So you have to be able to describe what current is. You're going to calculate current, charge, and time in questions. Okay. So to get you thinking about current, first of all, what is this? Okay, pause the video, have a wee think, and then I'll tell you the answer. I'll give you a wee 2-second break every time I say pause the video, so that way you don't miss any information. Okay, so hopefully you got that. This is a fuse, and if you've ever opened up a plug, or if somebody's ever said to you something's not working, check the fuse. This is the thing that you are looking at inside the plug. And the bit I want to point out to you is the bit where it says 3 amps, 5 amps, and 13 amps. Right? You've come across amps in third year. It's a unit for current, but what does it mean by having 3, 5, and 13 there? Okay, why is it important that we need to have different ratings of fuses, and how do we use them? So we'll talk about what the current is, and then we'll talk about how these fuses are actually used in your next lesson. Okay, so first of all, current is a flow of charge or electrons. Okay, in fact, it's a flow of negative charge, which are called electrons. Now, you might remember this from third year. I've got a motorway with cars going down it, or water flowing down a river. And the idea here is to give you a model. So when we start talking about electric circuits, you can sort of picture what's actually happening in the circuit. Because you can't really see current and you can't really touch it, it'd be quite dangerous. It's a good idea to have a model to try and explain things and allow you to visualize what's happening. Now, a wee note here, however, a model is only as good as until it stops working. And what I mean by that is the model isn't perfect. It will work generally, but there will always be something that maybe doesn't quite fit the theory. And that's how scientists come up with new theories. It's that they develop a model, they test it by experiment, and if the experiment matches the model, brilliant. If it doesn't, it means the model might be wrong, so they've got to go back and come up with a new model and do experiments to check if that model is correct. And you've probably heard a lot about this with the COVID-19 modelling, how, if we do this, the number of deaths will go down. If we don't do this, the number of deaths might not go down, etc. Okay, it's the same idea as that. So here's another model of an electric circuit. You can think of an electric circuit as being like a racetrack. So that's shown in my diagram here. And the charge is like the race cars which go around this racetrack. And when it completes one complete circuit, that's like the electric current going one complete cycle around the racetrack, or the circuit rather. Now the key thing to remember though is that it is only negative charges which move. Positive charges tend not to move, and certainly in circuits, an electric circuit, it's only the negative charge which will move. So that wee positive there was a deliberate mistake there. Okay, so moving on, here is a more specific definition of current, which is what I expect you to learn in Nat 5. So the first two slides was sort of like a revision slide. So current is the flow of charge per unit time. So you need to remember this. So I'm going to put a wee asterisk around there. And notice how we are being a bit more exact here. The language is also more technical. Before in S3, we just said current is a flow of charge. I'm now saying to you the proper definition is a flow of charge per unit time. And that's really important. So that's a word definition. There is also an equation definition. And the reason why we have an equation definition is because maths is the language of physics. It's how we describe things in a really formal and technical way. So here's the equation. Okay, I is equal to Q over T, or the way you will find it in your equation sheet is Q is equal to IT. So this is the one that you will see in your relationship sheet. I'll try and post that in the files a bit later on at some point. And this is how you'd rearrange it to give you the current. And this is really important because if you think about it, remember I stands for current, which is measured in amps or amperes. We usually just say amps, or we can just write the capital A as the unit for the symbol. So remember from the starter, 3 amps, 5 amps, 13 amps. Q is a charge in coulombs, which has the letter C. Okay, hopefully that makes sense. T is time, which is always in seconds. So that's something you're familiar with. Okay. Now, if we look at the equation, this is quite interesting because we've got Q divided by T. And so that's really another way of saying charge, which is Q, and the line means per second or per unit time. So can you see how the word equation links with the actual maths equation? Current is equal to the charge per unit time. Okay, so if you can't remember the word definition, you can always go to the equation and figure it out from there. Now, I know some of you quite like having the triangle, so that's a triangle there. I would recommend you copy that down because we're going to do some worked examples. Okay, so one of the best ways to learn how to do physics is by looking at worked examples and trying to figure out how do we apply the knowledge and what kind of tricks and tips can we use to make it easier to solve the problem. So I'm going to give you 3 examples. This is one that I've made up myself to show you the basic idea, the process, which I think you all know, because what does KFC stand for? Hopefully you said Kentucky Fried Chicken, right? Okay, so know it, find it, calculate it. There will then be 2 examples which are taken from past paper questions, and so that shows you the level that you need to be working at if you want to do well in physics. So let's make a start on this one here, okay? So following KFC technique, remember you've been doing this since 3rd year. KFC, know it, so know what we've got from the question. So the first thing we've got is Q, which is 150 coulombs. So we write that on the side. Now, in fact, if I'm correct, I've got this animated. Yep. Okay. Now, time is 2 minutes, but remember, it's always going to be in seconds. So to convert minutes into seconds, we multiply by 60, and remember to put the units at the end. And you can see now why I've asked you to do a lot of work on converting units. I just take it for granted now you know how to do that. What's the current in the circuit? That's the thing it's asking us to find. So it's always handy to write that down. And if you do this, you can see we're looking for an equation that has Q, T, and I in it. Now remember, in the exam, you will have a list of all the equations that you're going to learn. So even if you don't know what you're doing, you just look at the equation list and say, which one has Q, T, and I in it? Anybody can do that. There's really no physics there. The physics is in you writing down the quantities and putting them in the correct units. So once you've done that, you write down the equation, you plug in the numbers, and you get your answer with the correct units. Okay, now the way I've set this out is really important. Again, I showed you this in 3rd year, but the reason for that is because of the way the marks are given out. So this is exam technique we're looking at. You would get 1 mark for writing down the equation. Okay, and my top tip for you is write the equation as you are given it in the actual relationship sheet. I know some of you are really good and you might want to jump straight to the equation I is equal to Q over T. Okay, that's perfectly fine, but supposing you wrote this equation wrong, and this was your very first line, you would get 0 marks, right? Because that's wrong physics. You do not get any marks for wrong physics. In fact, we stop marking. You then get 1 mark for writing down the numbers in the right place. So substituting the right numbers will give you your second mark. And then you only get 1 mark for writing the correct answer with the correct units. So if you follow this method and you make a silly mistake at, say, the last point, you can still pick up 2 out of 3 marks. That's 67% roughly. That is a grade B. If you just write the answer down and it's wrong, say for some reason you wrote down 1.2 amps, that could be considered wrong and you would get 0 marks even though you've probably done the exact same work as writing it all out. So this is why I always tell you, write down your equation, put the numbers in, write your answer with the correct units. That's exam technique to get you to pick up marks. Okay? So to summarize, we're using our MTV technique KFC. Know it, find the information from the question, make sure they're in the correct units, find it, find the right equation. For this, you won't really struggle because you know it's always going to be Q equal to IT. Then calculate it. Substitute your numbers, use your calculator, write your answer with the correct units. That's the process. That's what I want to do every time. Let's look at how we do that with some real exam questions now. So as I said, this is an actual exam question, so let's have a read of it. It says, a hairdryer is connected to a 230 volt supply. The current in the hairdryer is 2 amps. The electrical charge that must pass through the hairdryer in 5 minutes is which of the following? Okay, so this is a multiple choice question. So let's have a look at it. So first of all, we use our KFC technique. So we know it. So let's write down what we've got. We've got 230 volts. Okay, is it in the correct units? Yes, so we're fine. We're told that the current in the hairdryer is 2 amps. So is it in the correct units? Yep, so we can just carry on. I'm just going to write 2 amps here rather than 2.0 to make it easy for me to actually do this. And then we're told that they want to find the electrical charge. So that's Q. So there's a question mark there. And then we want the time, which is 5 minutes. Now, is the time in the correct units? The answer is no. So we convert that. So remember, it's 5 times 60, which is 300 seconds. So again, can you see how important it is to learn how to convert those units? We take it for granted. You won't get any help in that in the exams. You have to know that off by heart. So that's 300 seconds. So that's a know it stage. Find it. Obviously, you would have your relationship sheet in front of you. We don't have that just now, but we can see we've got V, I, Q, and T. We want Q, so the equation must have Q in it somewhere. And if you check your equation sheet, if you could do that, you would find it's simply Q is equal to I, T. Hopefully, you saw that straight away. The V, you might ask, why is that there? Well, really, that's a red herring to try and confuse you, right? Remember, we're trying to see if you understand the physics. Now, for me, once you've got to the equation stage, the find it stage, there really is no physics left. The rest of this is now just a maths exercise. You just plug in your numbers and you get your answer. So 2 times 300. And the answer there, if you work it out on a calculator or you can do it in your head, is 600 coulombs. So the answer there is letter number C. Okay, so did you see how I applied the same technique as before? KFC, know it, find it, and calculate it. Now in this case, all of that work was only worth 1 mark. Right? So when we do multiple choice, be prepared to do a fair bit of working to get that 1 mark. Okay, folks? If you're not sure, play the slide again and just review how to do that. Let's look at our final example. Okay, so a bit more of a longer question here. This is part from section 2 of the exam paper. So it says electrical storms occur throughout the world. During one lightning strike, 24 coulombs of charge is transferred to the ground in 0.0012 seconds. Calculate the average current during the lightning strike, and it tells you something else in part B, which we'll read later on. Okay, this is what I call a standard 3-marker question, because it's asking you to calculate something. So it's using our KFC technique. So tell you what, pause the video, try it yourself, and then I'll come back with the answer. You can play the rest of the answer. So KFC technique, remember, know it. So first of all, we've got the charge is 24 coulombs. Is it in the right units? Yes, it is. So we can just write it down as it is. Okay, we know the time is 0.002 seconds. Is that in the correct units? Yes, it is. Now, how could they have made this question harder? Well, they could have given you the time in milliseconds rather than seconds, so just be aware of that. Now, you might get put off because it says the average current. Well, the average current is really just using the same equation. Q is equal to IT. It's the only equation we use, so in this case we can ignore the average, but it's just Q equal to IT. Write your equation down, so that's me got 1 mark straight away. Notice how I'm not rearranging it, even though I'm looking for current, but I still get 1 mark for putting in the right equation, because I've shown I know what the physics is. I put in my numbers to get my 2nd mark. Okay, and so that means I've now got my 2nd mark here. Apologies for the bad handwriting, but I am doing this on my mouse pad. So far I am sitting at 67%. That is a grade B. In fact, I'm only 3% away from getting a grade A. Okay, how easy is that, folks? Just by following that same process. And then this is where the maths comes in. I is equal to 24 divided by 0.0012. So I've not got my calculator on hand, so I'm just going to let you work that out. I'm sure you can do that on your calculator. And then remember, you get 1 mark for the correct numerical answer and the units as well. Okay, so work that out, folks, and that's you got your 3 marks. Okay, so hopefully fairly straightforward. B, the charge on an electron is minus 1.6 times 10 to negative coulombs. So notice we're going to use our standard form here. Determine the number of electrons transferred during the lightning strike. Okay, so this is a bit of an odd question. It's only worth 1 mark, and to me, this isn't really anything to do with physics. This is more of a maths question, okay? Because it tells you how much charge 1 electron has, and it's asked you how many electrons there are. So there's really no equation for this. It's a bit like me saying to you, an apple costs 10p. If you spent £1 on apples, how many apples did you buy? Okay, so it's the same idea. So all we do here for B, I'm going to do it at the top here, is we know the total charge is 24 coulombs. Okay, we know the charge for 1 electron is this thing here. So to get the number of electrons, we simply do the following: 24 divided by 1.6 times 10 to the negative 19. Okay, and again, I don't have my calculator on me, so you can probably work that one out. If you can't, let me know and I'll post an answer on the message board, but you should be able to do that. And there's no units for this because we're simply looking for the number of electrons. Now, those of you who are really sharp will notice this is actually a negative, but I've ignored the negative here because really the negative tells me it's got a negative charge. Okay, so we can ignore the negative in this case. A wee pop quiz for you. If the charge of an electron is minus 1.6 times 10 to the negative 19 coulombs, what's the charge of a proton? Okay, post your answers on the message boards and I'll let you know if that's correct or not. I'm going to post a worksheet for you. Please do that as an assignment and I look forward to seeing your answers, folks. Okay.